Compute the force on a gate due to seawater pressure. Gate is 5 feet into the slide. That means we have a rectangular gate. And one thing to note here as we look at the gate, all this area right here, that's atmospheric pressure, so it makes it a little bit easier when we calculate things out. So we need to find the resultant force, and then we also have to find out where it's located. So to find the resultant force, we're going to integrate the pressure over the area. And as we saw, because of the linear equation, everything we talked about in the lecture, and because it is atmospheric pressure on the backside, all this is going to reduce to is gamma times the height to the center of gravity. That's going to be our pressure at the center of gravity times the area. So as I take a look at things here, it's 15 feet to the bottom. That's not where the center of gravity is. The center of gravity is right there. Let's use the right symbol because that's for center of pressure. And so if I look at this, because of the way the angle is tilted, since the gate is tilted, we have to figure out what is, oops, sorry about that. We have to figure out what this height is here. And it's a 6 on one side, it's 8 on the other side. So that's going to tell us, because it's a 3, 4, 5 triangle, the gate width between A and B is going to be 10. And so halfway up is going to be 3 feet. So the height at the center of gravity is going to be our 15-foot depth, minus, we've got to come up 3 feet. So our height for the center of gravity is going to be 12 feet. And that's was a pretty common mistake with this problem when I've given it for exams before. So now we can calculate out the force. That force is going to be 64 pounds per cubic foot is our specific weight of the water. Height to the center of gravity is 12 feet. And then our area, it's a rectangular area. Once again, 3, 4, 5 triangle. So I know between A and B it's 10. It's 5 feet in the board. So that's going to be 10 feet times 5 feet. So a 50 square foot gate. And when I calculate this out, the amount of resultant force on this is 38,400 pounds of force. Foot times foot squared is foot cubed. That'll cancel out, leaves me pounds of force. So that's what I'm looking for. Now the next thing is, where is that centroid located? YCP is equal to YC plus gamma sine theta IXC over pressure at the center of gravity times the area. Once again, this is the formulation of the equation from your engineering equation manual. The only difference between this and the book is the introduction of that y sub c. And remember, y sub c is this distance all the way back up to the surface of the water. And we're going to solve YCP, which is that distance all the way down to the center of pressure. So if you were solving this from the book, the only difference is in the book, YCP is just the distance between the center of gravity and the center of pressure. They're along the same axis. That's the only difference between the two. Let's solve it like we're solving it out of the engineering equation manual, though. So YCP, what's that going to be? Well, that's going to be our depth to the center of gravity, which is 12 meters. Oh, excuse me, 12 feet. 12 feet divided by the sine of the angle. And the sine of the angle is 6 divided by 10. Because sine is the whole opposite over hypotenuse. And so we can just use 6 over 10. So we're going to add to that gamma 64 pounds per foot cubed times the sine of the angle, so 6 over 10. IXC. What is IXC? Well, this is a rectangular gate, so that's a pretty easy one. It's going to be 1/12 base times height cubed. So our base is going to be 5 feet times 10 feet cubed. Then we're going to divide that by our pressure at the center of gravity times the area, which in this case is also our resultant force, so I'll just write in that 38,400 pounds of force. So I look at the units, I've got feet over here, so if I'm adding it to something, we really better hope that this all works out to be feet. Pounds force here, I've got cubic feet here, cubic feet here. I'm left with feet. I can add those two together. And so what I will get is 20.417 feet is the location of my centroid. Now, if I was trying to solve this using the Book's equation, where YCP is just the distance between the center of gravity and the center of pressure, this actually works out to be 0.417 feet, because the distance from the surface to the center of gravity, that 12 divided by 6 over 10, is 20 feet. So that's YCP. It's a rectangular gate, so there is absolutely no difference on the x side, so XCP would end up being 0. But once again, symmetrical gate, that's the kind of thing that we have.